In this lecture, we discuss about tracing of parametric curves. Suppose the equation of the parametric curve is given by x equal to f of t, y is equal to g of t. Parametric equation means what? Here x and y are two different dependent variables which are only depending upon one variable. So that is called parametric curve. Then the tracing of for tracing the curves, if it is possible to convert the given equation into the Cartesian curve, then we can trace as per the rules of Cartesian curve, or we check the following. So first thing what we can do, if the given parametric curve is x equal to f of t, y equal to g of t, then we will try to convert this parametric equation as a Cartesian curve. Then we can trace as per rules of Cartesian curve. Otherwise, we can trace the parametric curve as follows. So first thing, the first point which we have to look to trace the parametric curve is limitations. Limitations means what are the minimum and maximum values of x and y. So range of x and y, that is minimum and maximum value of x and y. This is called limit of the given parametric curve. The second point is about symmetry. There are following symmetries. The first symmetry is about x-axis. If x is even function and y is odd function with respect to t, then the curve is symmetric about x-axis. For example, x equal to 80 square, y is equal to 280. So if we want to trace this curve, now this is nothing but now if we square it, what is y square? Y square is equal to y square is equal to 4a square t, and if we write down this one 4ax, so 4a into at square, so it is 4a square t square. So this is nothing but x equal to 80 square, y equal to 280 is nothing but y square equal to 4ax. It is a parabola which is symmetric about the x-axis like this. So the parametric equation of this parabola y square equal to 4ax is nothing but x equal to 80 square, y equal to 280. So if you want to check that the given parametric curve is symmetric about x-axis or not, so we have to just check that if x is even function and y is odd function. As here, yx is even function because the power of t is 2, and y is odd function because this t has power 1. So x is even function, y is odd function. Therefore, this curve is symmetric about x-axis. Similarly, about y-axis, it is just opposite. If x is odd function and y is even function. So now this can be checked in two ways. The first way is if x is odd function and y is even function with respect to t, then the curve is symmetric about y-axis. For example, x equal to 280 and y equal to 80 square. It is nothing but it is parabola x square is equal to 4ay. This is the parabola x equal to 4ay. And if we trace this parabola, we will get this type of figure. Okay, so now this is symmetric about y-axis. And here, just look here, x is odd function because the power of t is 1, and y is even function because the power of t is 2. So this is the one way by using we can check it is symmetric about y-axis or not. And we have another second method to check the symmetry about y-axis. If x is odd function and y is even function with respect to pi minus t, then the curve is symmetric about y-axis. It is applicable only for the curves which contains the trigonometric functions, right? So if x is odd function and y is even function with respect to pi minus t, then the curve is symmetric about y-axis. So I know since we are replacing t by pi minus t, so it is only applicable to the trigonometric functions like that x equal to a cos t, y equal to a sin t. This is nothing but the equation of circle, because if we squaring and adding them, what we will get? X square plus y square is equal to a square cos square t plus sin square t. A square t we will take outside. So now it is nothing but 1. So we are getting x square plus y square equal to a square. So this x equal to a cos t and y equal to y a sin t is nothing but it is the equation of circle. So now here, if we replace t by pi minus t, just look here, x equal to a cos pi minus t. And we know that cos pi minus t is nothing but minus a cos t, right? So x is what? If x is minus f of x, we can consider that this x is minus a cos t with respect to pi minus t. Similarly, if we replace for y equal to a sine pi minus t, but sine pi minus t is nothing but sine t. So we can write down a sine t. So here x is odd function with respect to pi minus t and y is even function with respect to pi minus t. So therefore, this is also symmetric about y-axis. So now, while checking the symmetry about y-axis, we have to check these two properties. The third symmetry is about opposite quadrant. If x and y both are odd function with respect to t, then the curve is symmetric about opposite quadrant. For example, x equal to ct and y equal to c by t. This is nothing but if we just multiply this curve xy equal to ct into c by t. So this tt will cancel. It is nothing but xy equal to c square. It is not. It is a rectangular parabola. It is a rectangular parabola. So just look here. It is symmetric about the opposite quadrant. So for opposite quadrant, symmetric about opposite quadrant, both the functions should be odd functions. So these are the three symmetries in case of parametric curve. As we have already seen that there are 6 symmetries in case of Cartesian curves. So we have only these 3 symmetries. Now the third point is origin. How to check that the parametric curve passes through origin? So for this purpose, we have to find for any value of t, if x is equal to 0 and y equal to 0, then the curve passes through origin. So first thing, we have to find out the value of x and y, or for which values of x and y t, the value of x and y are 0, then we say that the curve passes through origin. Now how to find the tangent at origin? So tangent at any point of the given curve is given by dy dx is equal to dy dt upon dx dt. So now since we have y is function of t and x is function of t, so we have to find out the total derivative of y with respect to t and x with respect to t, and then we are able to find out what is the value of dy dx. This is nothing but the tangent at any point of the given curve. Then we also check there are is any special point, and then if it is, we are able to find, we will try to find out and also we calculate the table values. We can find some points on the curve by observations and make a table value or table for t, x, y, and dy dx. So we will make a table. So first, like that, suppose we have the value of t, value of x, value of y, and dy dx. So now suppose we have, for example, if we have x equal to a cos t, y equal to a sin t. So we will try to make, for example, if we put t equal to 0. So t equal to 0, so cos 0 is 1. So x is equal to a, sin 0 is 0, so y equal to 0. And dy dx, so we will try to find out what is dy dx. It is nothing but dy dt. So a cos t upon minus a sin t. So a will cancel, it is minus 10t. So this is what it is dy dx. So 10 dy dx means if we put t equal to 0, 10t is also 0. So this is what it is dy dx. So in this manner, we will try to find out the different values for t, x, y, and dy dx, and we make a table. The next point is asymptotes. We will also try to find out the asymptotes if possible. Otherwise, most of the time there should not be asymptotes in uh, parametric curve. And the last point is reason of absence of the curve. For any value of t, if x and y are imaginary, then the curve will exist on that region. For any value of t, if x and y are imaginary, then the curve will not exist on that region. And the second one is if both x and y are periodic functions of t with a common period, then we need to study the position of the curve for one period only. So if there's like that, suppose cos t and sin t are periodic functions, so we have to only check for the one period. No need to check for the remaining terms. So these are the some points. By using that points, we are able to trace any parametric curve. Thank you.